Hello guys, welcome back to the video. So today we are going to see problem number 3025. Find the number of ways to place the people. Okay. So in this it's a 2D array and we're going to see two solutions for this. Okay. So let's start by understanding the problem. You are given a 2D array points of size n into 2 representing integer coordinates of some points on a 2D plane, where point of I equal to x of I and y of I. So we are given a 2D array with points like x and y axis, there are points on it. Count the number of pairs A, B, where A is on the upper left side of B, and there are no other points in the rectangle or line that make including the border. Okay, so they are telling return the count. Okay, we have to find such 2 points that A and B where they make a rectangle and nothing is inside them. No other point lies inside them. So let's take example like 2, 1 and 6, 0. Let's take this example. So these 2 points will make a rectangle. Okay. So we need to find such pairs. But they are telling with that there are no other points in that rectangle. Like here there should be no point here. Point can be here but not inside this or lying on the border. They're also mentioned including the border. So it should not be on the border. Okay. Hope you get the problem. Let's try to see some examples. Okay, so they have given 1 1 2 2 and 3 3, so all lies in one direction, so no one lies to the left side. Okay, so they're also telling it should be on the left side of that to make the rectangle. So nothing is on the left side. If you can see this point, nothing is on the left, nothing is on the left, again nothing is on the left, and these are all correspondingly on the right hand side. And if we consider 2 2 and 1 1, so 1 1 is left to 2 2, correct, but it's on the downward side. So we are told like it should be in the upper left. As you can see here, it should be in the upper left. So we cannot make any of such pairs, and that's for we are returning 0 here. Okay. The second thing, let's look into this. Okay. So we are given 6 2 4 4 and 2 6. So if I just zoom in a little bit, okay. Okay. Hope you are able to see it. So here it's 6 2 and its left is 4 4, so this is a valid rectangle. Then again 4 4 and 2 6, it's also valid rectangle. But here if you see 6 2 and 2 6, it's also a valid rectangle, but here 4 4 is in the middle, so it should not lie inside that. Okay, then let's see another one example. So there are these 3 point 3 1 1 3 and 1 1, so they are placed in this plane. Okay, so this is 3 1 1 1 and 1 3. Okay, so you see they are also considering a straight line. So if that thing is making a straight line, not a whole rectangle, then also it's fine, it's considered. Here also they are making a vertical line, here they are making a horizontal line, and this one is not valid because you see on this rectangle the third point lies, this third point 1 1 is lying on this rectangle. So hope the question is clear. We got the edge cases also. Okay, let's try to understand it, how we can solve it. I'll just zoom out a little bit. Okay, so let's take this example only. Okay, this example we'll take. So first, what we need to find, we have 3 points. Okay, what we can think of, just not telling you the answer directly, but letting you to think about it. Okay, so suppose we have 6 2 as the first point, 6 and 2. Okay, we will check it with all the points if we are making a pair or not. Okay, so first we'll see this both 4 and 4. So how can check this? See, this is x, this is y, this is x, and this is y. How we can check if it's making or not? So for that, if you see here in this rectangle, suppose I place this 6 2 here, 6 2 here, and 4 4 here, and it makes a rectangle. Okay, so for this you see this x should be greater than this x. Okay, so we got our first condition, so that it makes a valid. So the x1, let's take, should be greater than or equal to x2. Okay, so let's give this x1, x2, y1 and y2. Okay, So x1 should be greater than equal to x2. This is the first one. So let's see what y plays the role. So this is the y1 and this is the y2. So you see y1 should be less than equal to y2. If it's not less than equal to, it will go downward. The other point will go down and we don't want that. We know upper one. Right? So these two conditions, if these two conditions are fulfilled, right? I'm just doing a simple thing, just checking the conditions, not nothing else. Okay. If these two conditions are filled, we can say that these 2 points make a valid pair. Correct? Okay, so we got one thing here. We can just check it out. Okay, the upper A is on the upper side of the B. So we can check with this condition. Okay, the remaining one, there are no other points in the rectangle. So to check that, we have to see all the points if they are there in the rectangle or not. Right? As of now, we'll check all the points. Correct? So let's see. Okay, this one is done. Okay, this part you got it. Now checking part, how we'll check it? I will just erase this. Take example which intersect. Okay, the points are 6 2 and 2 6 2 6. Okay, this is x1, this is y1, this is x2, this is y2, and the third point is x3 y3 4 4. Okay, so we know this 2 and 6. Okay, and 6 and 2, this makes a rectangle. Okay, so here both conditions are filled. Like x1, first condition was x1 should be greater than equal to x2, and in this case it is right, 6 is greater than equal to 2. The second condition was y1 should be less than, because it should be upper, right? So y1 should be less than means this 2 should be less than equal to the y2. Okay, then only we are getting a valid pair. First of all, y2 is 6. Okay, so it's greater than, but so it's correct. So we are getting a valid pair here. Now next we need to check the other points if they lie between them or not. Okay, so I'll just erase this part. Okay, and how we can check if it lies or not? So 4 4, we'll mark it here. 4 4, we know it lies because we have seen this example here. Okay, I'm just trying to find how we can validate that it's inside that or not. Okay, so let's take the x range. This is x and this is y. Okay, why? So what is our x range? What is the range of x? It is 2 and 6. Correct? So if it lies between that, means the x3 should not lie between x1 and x2. Correct? So we'll write like this, like it should be x1. Okay. Okay, it should be just a minute. Just give me a minute. Okay. So x3, we are talking about x3. It should be, if it's less than equal to x2, x1, sorry, and x2 less than equal to. You're getting it? I will write the values also. So x2 is 2 in our case, 2. Okay, less than equal to. What is x3? x3 is 4 and less than equal to 6. 6. So this is the first condition. We are just taking the x-axis and we are seeing if this x lies between our 2 points, x1 and x2. We are just checking that. So it should not lie between them. Okay. But is this sufficient? What do you think? So suppose this is 4 and the other point was, suppose the other point was 4 6. 4 6. So if we have written only this condition, then our answer will be wrong because 4 6 does not lie in this rectangle because it's 6. So we need to write some condition for y also. Correct? We find it like some of the other condition we have to write for y. So let's try to find for y also. So y also will write the same condition that between that range, between the two range, it should not appear. So let's take the minimum, that is 2. 2 should be less than equal to, okay, what is here? Here it is 4. and again equal to, what is here, it is 6. So 4 should not lie. Means we are checking if it lies, then we will give it as false, and that we cannot make a pair because some point is lying between them. Okay, so this is how we can check it. We'll take this y1, sorry, y1, y2, and y3 here. So we are doing what we did for x also. We are checking if this point lies between that x-axis, means the two x points. So it lies between that. So this both condition together gives us answer, yes, a point lies between that rectangle or not. So hope you get it clear. I will just erase all these things and we'll see one more example for this. Okay, the lying one, we'll take this one. Okay, so here they are telling it's wrong, correct? So we'll take that points and try to recreate it. So the points are, I'll just zoom in if you're able to see it. The points are 1, 3. Okay, the points are 3, 1, 1, 1, and 1, 3. Let's make it 3, 1, 1, 1, and 1, 3. So how we can say if it lies or not between that? Okay, so this is our rectangle, these are our 2 points. So this one we are considering as our first point, x1, y1, and x2, y2, and this is our x3, y3. Okay, first we will do the validation, like if it lies between them. So for that we have x1 should be less than equal to x2, and that is true in our case. 3 is sorry, greater than, this is greater than, 3 should be greater than equal to, so 3 is greater than equal to 1. Okay, so first we will check if it's a valid two combination pairs or not, a and b. And here we are seeing y is 1, that is less than equal to 3. So we can say this is a valid pair. Okay, now we will check like if it's having a intersecting point or not, if other points are coming between them or not. So we have another point 1, 1. Okay, so what was our condition? This one. Okay, the minimum, let's see first the x-axis. Okay, what is the minimum here for x-axis? It is 1. So 1, it should be greater than equal to and less than equal to 3. Okay, so as we can see, it lies between that. Okay, because 1 is equal to 1, so it lies inside that, and we'll tell this is not a valid pair because some or the other point intersect. That's why they've given a cross here. Okay, hope you get it. So let's try to write down the problem now. So I've given a clear implementation here, so you can pause the video and try to do it by yourself or follow with me. Okay, let's try to do it. So we'll take int answer equal to the 0. So this will contain the count of the valid pairs. Okay, so we'll try to write first loop and okay, this is done. Then here we'll write the points int x1 equal to points of I 0. This is y1 and it will 1. So initially what we are comparing, that point we have here. Okay, then we'll go into another loop int I equal j equal to 0. Okay, we have to compare with every point, so we'll again start with 0. Okay, we'll not start with I plus 1 or something like that. Okay, then we need to also see, like we will avoid if I is equal to j, we'll just continue it. Okay, we don't want to compare these 2 points because it's the same point, so no point of comparing it. Now we'll take this, we'll do 2 I equal to 2 points of, instead of I will take j now. Okay, we got the second point. Now we'll apply the first condition. What was our first condition? Like x1 should be greater than equal to x2, because our x1 should be ahead and the x2 should be in the left, that's why. And with that, our y1 should be less than equal to y2, and we want upper side, right? So our x1 point is here, so we want our second point to lie slightly above or equal to that, not below that, so we're writing this condition. Okay, so now our first condition is satisfied with this. Okay, now we have to check all the points, like if any point lies between that rectangle. Okay, so for that also we are again going to loop it for, again we'll take this loop. Okay, for anti idx, let's take idx here. Again we will loop it from 0. Okay, because we have to check every point, each and every point, if it lies or not. Correct. For this we'll write boolean valid equal to false, sorry, equal to true. So if it's a valid point or not, that will check after this loop. Inside this loop, we are going to check if we got it invalid. We'll just do a break and we'll write valid equal to false and return that. Okay. And in this, valid, if it's valid, we'll doing answer plus plus. That's it. Okay. Now we have to check with every point if it lies or not between that. So let's make the 2 points. X3, Y3, and here it will be idx instead of j. Okay, we got the 3 point. Let's do first x-axis boolean x valid x equal to. So if x is valid or not, how we'll going to see it? First we'll write x3. Okay, so we wrote x3, then x2 should be less than equal to. Okay, should be greater. Just a minute. I'll not write like this. It will complicate the things. I'll just write like this. If we'll see if it lies between that or not. X2 is less than equal to x3. Okay, first thing, and x3 is less than equal to x1. So this is for x-axis. I'll just do an enter. Now I'll write for y-axis. Okay, for y1 should be less than equal to y3, and y3 should be less than equal to y1, y2. Okay, so these are the conditions. You can see the above one is for x-axis and the below one is for y-axis. Like that, x3 point should not lie between. If it lies, we are going to do valid equal to false and we'll break it. Okay, we'll just break it. Else we'll do nothing. We'll just continue that. Okay. One more thing we are missing here is that what if the point is same, then it's gonna break it. So if I is equal to idx is equal to I, or idx is equal to j, we need to continue it. Okay, otherwise it will break it and we'll get always answer 0. We'll not get an answer here. So I think we have written everything. Let's go down and return the answer. Let's try to run it. Okay, we're getting something wrong. Okay, here we have not given and. Okay, error on 20. Yeah, the same thing. We have not given an and here. We missed it. Okay, so it's working fine. We are getting all the things correct. Okay, let's try to submit it and see if it's working for all our test cases. Yeah, it's working. So I will tell you one more thing. That's my intuition. I'm not sure if it will work or not. Okay. So here you see we are traveling from I to 0 to point dot length here also and here also. Can we eliminate that? Can we do something like that will reduce our iterations? What do you think? So what I can think about now is like if we just sort it in the order from the x-axis. Okay, so we'll take the highest x-axis as first and we'll compare with the right side part, because highest we are getting like I'll just write and show you. So we'll only take x point, like there are 1, 6 and 4. Okay, these are the points. So we'll take sorted with 6, 4, 1. So so we'll get first 6 and we'll compare with the right side. The 4 will not compare with 6 because there is no point with comparing 6. It will be always on the right side, right? So we'll always compare in the forward part. So that we can do here. Okay. Hope you get it. So suppose I have more x-axis like 2, 6, 8 and 9. So it will be sorted in descending order 8, 9 and 6, 2. So always I will be comparing 9 with the other parts, but comparing 6 and 9 is of no use because 6 will be somewhere here and 9 will be somewhere here only. So we don't want anything comparing with the right side. We only want to go to left side, right? So it will be doing that. So let's try to do that. Let's try to sort it. Okay. Arrays dot sort. Okay. In that, there is one catch again. Like what we have to do with this, like it's 6 2, right? And if we get another one similar to it like 6 1, what we have to do here? Okay, first we need to check this if it's similar or not, and on the basis of this, but if it's same, then what we'll do, we will do this ascending order. Okay. Okay, because why we want at the lower part, right? As we have seen here, why one should be less. So if this is the case, it will be sorted in this case 6 1 and 6 2. Okay, so 6 1 will be compared with 6 2 and we will get a valid pair. If it's not like that, if 6 2 is before and 6 1 is after, then will not satisfy this condition and will not be a valid pair and will not get an answer. Okay, hope you get it. I will write the code and it will be more clear now. Okay, arrays dot sort a comma b. I am using a lambda function. Okay, so here if a of 0 is equal to b of 0, then we need to return a of 1 minus b of 1. Okay, otherwise we'll return b of 0 minus a of 0. So you might be thinking, what is this? Okay, hope you know it. If you don't know it, I'm just doing like if a of 0 means there are matrix, right? So it's first both elements are same, then do sorting on the basis of this. This will sort in ascending order. Basis of y-axis, and if it's not the case, just do descending order on basis of x-axis we are doing. Okay, so now we have to change some points here. We will not change the whole code. I will be giving it correct, so it will be j plus 1, j plus 1. So we can remove this because it's always j plus 1, and here also we don't need to do anything. We'll do here idx equal to I plus 1, and idx should be less than j. It should be less than j. because we're going to this only, right? So if I is this, x is in the middle, so there is no point going beyond, right? So beyond we're going to get a valid point only. So only we'll check the middle points for that. If middle points are removed, then we are safe. It is valid. I'm just checking. Okay, I think it looks good. Let's try to run it. Okay. Oh, I forgot to write a return here. Sorry guys, my bad. Some syntax error. Then 10th line. Okay, I forgot to give this also. Let's try to run it now. Hmm, oh, I have not given which array to sort actually. I forgot that also. My bad. Sorry guys. Yeah, I think now it will run. Correct. Hmm, oh, sorry. Yeah, this is I plus one. Let me check the code. I think I made some syntax error. Hmm, this usually happens with me. Hmm, it will need a lot of practice. Okay. Yeah, it's working. Let's try to run it. Okay. Hope you get it. So I've tried my best to explain it. So here, let's try to analyze the time complexity. So this is log n. Okay. Log n. Then here we are iterating to three loops. This is the first, this is the second, and this is the third loop. Every time we are doing it, so it will be obviously n cube. So plus log n, okay, so it will be n cube only. So time complexity will be n cube. Okay, and space complexity will be big of 1 as we are not using anything here. Okay, so hope you guys like the video. Please share this video and subscribe the channel for such more videos. And if you have any doubt, if you don't understand anything, just comment down. I will try to help you. Thank you.